Hi, this is Dana Gardner, Principal Analyst at InterArbor Solutions, and you're listening to Briefings Direct. For those tasked with delivering unwavering performance of their apps and data, there have never been more unknowns to account for and manage. That's because today's hybrid clouds and mixed network environments come with a multitude of dynamic variables and an unprecedented degree of complexity. Yet modern digital business demands that the entire constellation of these far-flung cloud services, resources, and application constituent parts coalesce perfectly. The end result must be real-time and always-on user experiences that delight and business transactions that are both highly secure and never fail. Bridging the gap between such daunting complexity and awesome performance and security requirements means gaining the best visibility into all aspects of the hybrid and multi-cloud continuum. Stay with us now as we explore the ways that deep observability moves past the limitations of metrics, events, logs, and traces to deliver far richer and faster and leaner data-driven insights. By exploiting these new means of pervasive deep observability, the highest levels of security, performance, and agility can be attained by nearly any business and organization. To learn how, please join me now in welcoming our guest. We're here with Bassam Khan. He's Vice President of Product and Technical Marketing Engineering at Gigamon. Welcome, Bassam.
Hello, everybody, and good to be here. Thank you, Dana.
We're delighted to have you. Bassam, what are the main pain points that you're seeing in the market for the cloud ops, sec ops, and network ops teams as they are trying to keep their environments performant, dynamic, and responsive, given all of this difficulty and complexity?
Yeah, great question. It's dynamic, performant, secure, and economical. That's the other aspect that we keep hearing. So the pain point is really for these operations teams nowadays to not get in the way of progress, not get in the way of application development and business transformations and workload modernization, application modernization. So progress today can be defined truly as an organization's ability to move fast by leveraging all of the cutting edge technologies, applicable cutting edge technologies that are out there today. The pain point also is that developers now have the ability to move very fast without any involvement from IT groups, particularly from operations, until something goes wrong. And whether an application breaks, costs are overrun, this is costing us a lot more than we expected coming into the project, or the worst case, some kind of security incident happens. That's the pain point. That's the difficulty, is that the operations teams tend to be an afterthought up until today, and we are starting to see some transitions happening there.
So rather than that lag, rather than reactive, you want to be as proactive and get out in front of these as much as possible, and that certainly requires more visibility, more knowledge, more understanding of what's going on.
That's right, exactly.
What are some of the obstacles to get to that, forward approach to being out in front around such things as adversity identification and rapid remediation response? How do you tackle that?
So one of the main obstacles, Dana, is what you just mentioned, which is getting involved early. These development teams have the ability to move very fast using their own cloud platforms de jour, their favorite environment. Now, having visibility from an operations perspective, from a security perspective into an infrastructure de jour, or the app, or the developer, whatever the preferences are, it's not easy, right? Because every platform, every infrastructure, every cloud container, hyper-converged environment has its own way of getting visibility, its own methodology for accessing, let's say, traffic, for being able to scale up, being able to see VMs and containers as they pop in and out of existence. That's the hard part, because the orchestration, automation for every platform is different. And that's what makes it very, very hard. So in some environments, you have simple things like VPC mirroring. So I get all the packets coming in. I get all the visibility I need from a security perspective. Some environments, like let's say Azure, doesn't quite have its packet mirroring capability. There's eBPF sidecar, other technologies involved in container. So The best way that the operations team can get involved early is by showing value, adding value that's tangible and front and center of cloud developers and DevOps, Cloud Ops, that team. To this day, the development team, the cloud team, the DevOps team, they tend not to look at the infrastructure. In fact, they don't want to worry about the infrastructure. It's something they're built to not have to deal with. However, there's value that can be extracted from the infrastructure information, and that is what the security team and the operations teams, network operations, IT operations, can bring value to those teams.
So we have a mixed bag of deployment options, many different variables and ways in which they can gather and share information. That doesn't give us the complete picture. We also have oftentimes a chasm between what the developers are doing and what is going to happen in operations. But then even the security people have to come into both of those teams and find out more. So it's a rather difficult challenge. What do we start to think about when we want to get a solution to that? How do we start thinking about achieving almost the impossible end-to-end and cross-chasm types of insights?
There are many different ways of seeing what's going on in your environment, getting those insights as the data points for those insights. There's something called MELT, which is metrics, events, logs, and traces, which is the most common ingestion telemetry in input data that all of the cloud tools operate in. So that's one whole area. And as you know, logs are quite informative. They provide a very, very broad view, whether it's from on-premises or cloud type of workloads. And that's a good normalization mechanism. However, that's not sufficient. And that's not sufficient because logs are only tracked for environments that's creating log files. There could be hosts out there, there could be communications out there that is not generating the level of log file needed from a security perspective. So what we're finding is while a lot of people feel very comfortable in that environment data, when we bring up this whole nother telemetry based around the communications that's happening between the hosts, not just for managed endpoints, not just for managed hosts, but for all hosts in the system, all communication system, our customers are saying, wow, that is something that's very, very cool and very helpful that was never possible before.
All right. So how do we get past the MELT into deep observability, and what tools are available to us to excise that data and provide that fuller, richer, faster view?
So the tools tend to be kind of the same tools. If I can pull up a slide here, Dana, let me go ahead and share the screen here. We have been talking to a lot of customers over the past many months and going well into years about what to do, like sort of what, where is the industry headed? Where's the industry trend headed? If you talk to analysts and other industry gurus, they will talk about where things are headed from a technology perspective. But we took a different approach in talking to probably over 100 closed-door conversations, looking at our customers' futures, talking to our partner vendors, and then other knowledge we have in the industry. So we took an approach from a teams, tools, and telemetry perspective. So the people, what are the roles and responsibilities? So most of the cloud initiatives, these are the different teams that are responsible for deploying and managing. So that you've got developers on one end, all the way through other operations, all the way over to the NetOps side. Now, these teams tend not to be very cooperative, collaborative. As we just mentioned before, the DevOps team is not pulling in the SecOps and NetOps as early as possible, as they should be. And SecOps team, as a result, has to play catch up. NetOps team has to go into a mode of mean time to innocence to say, hey, this was not an infrastructure thing. This is some other application related issue. What we've found, Dana, is this relationship is actually starting to improve, and people are starting to become more collaborative. It's not like overnight shift, but it's starting to get better because of security. Security is sort of the common denominator, the common cause across all of these groups. So nowadays, a DevOps person is much more conscious and spends more time thinking about and working on security-related issues. The same thing with NetOps. I joined Gigamon about 4 years ago, and I've had lots of conversations over the years with NetOps teams and SecOps teams. And there was a chasm 4 years ago. There was this much stronger chasm between the two groups, and contention, I think, is a better word, or at least harsher words than that. Today, what we find is there's much better collaboration. It's not perfect yet relationship-wise, but there's better collaboration. You cannot be a network engineer, a network operator, and not spend at least half of your time working on security-related issues. Now, security spans a lot of different areas, right? What we're finding when we talk to customers, when we talk to C-level people in very large IT organizations, is when it comes to detection, that's not going to change. That's going to stay a SecOps function, detection, and that function will reside in the SOC as far as we can tell. However, when something is detected, a breach is detected, a cyber threat actor activity is detected, that's when the other teams are involved in taking the response, working on remediation, and then even further, more proactive stance around vulnerability mitigation and detection and management. And that's where all of the teams are involved working together. So once you set down let's say a zero trust, which is starting to pick up more and more, kind of an architecture, the teams from DevOps to NetOps and SecOps, obviously, are much, much more involved. Now, the challenge has been the fact that Melt is very, very powerful information. However, the tools that people are using are siloed, defined based on the ingestion data that they're getting. So when you look at metrics, events, logs, and traces, that's the ingestion point for the tools that the developers are working with. When you look at security-related tools, particularly data center security-related tools, which all of compliance is built on, controls, knowledge base, all of that tends to be much more around packet type of information, because that's what you had in the data center. So this chasm is what's causing a lot of problem, and not allowing a developer person, for a DevOps person, for example, be able to do security work because they're missing out on endpoints that are not managed, that don't have a observability agent. Let's say they're not seeing unmanaged traffic. There's not many security use cases they're able to get to. So that's the chasm, and that's what we're hoping that the industry can address and help out the IT world.
Yeah, I totally agree that security is providing a common denominator that joins culturally and in terms of their operational and process orientation, which is a good thing. A little bit late, but better than never. So the idea now that the security drives a common purpose, an assimilation value, we need to get the right data to that security value proposition. So deep observability pipeline, how is that getting the right information to empower security as an imperative, and then bring these teams together to take the proper action?
Let me answer that going back to the same slide here. It's a good segue here. So what we've talked about is the fact that the two worlds are separated. Even though a DevOps person wants to do security, their use cases and use their current tools, observability tools, in-house tools based on Kibana, Grafana, to do more security functions, they're not able to. So what we have built, so these tools and the data ingestion is causing the groups to kind of stay siloed, which is not ideal. And so what we've seen over the years, and it's Gigamon and other vendors as well, we brought in this notion of visibility fabric. What that does is, because the tools on the left-hand side cannot ingest network information like packets or flow records, what these tools have done, and including Gigamon obviously, is through deep packet inspection, we will open up the packets, we will look at what's inside the packets and create almost like an invoice, a bill of materials of what's in the packet, and we'll send that over to the tools using a format or technology or language that those tools can speak, which sometimes Kafka, sometimes JSON, depending on the tool. So now you're able to use the observability tools to be able to look at more and more security use cases, like, are there any self-signed certificates, which is usually a red flag? Are there any old SSL ciphers out there in production today, which is another vulnerability that needs to be flagged? So now that security tools can be, observability tools can be used for security functions, not just for managed hosts, but unmanaged hosts as well. Where deep observability pipeline comes in, Dana, this is something that Gigamont's introduced very, very recently, is we stretch that out further. So it's not just security information saying that Bassam is running cryptocurrency mining activity on some AWS, or there is cryptocurrency running. But what we can also say there is, and here's where Bassam downloaded some application, and then there was some command and control communication that went on. And then this crypto mining software was installed. All of this packaged into a contextualized export, a very, very targeted small export that gets sent to an observability tool, whether it's New Relic, Datadog, Dynatrace, AppD, or even a SIM like a Sumo Logic or Splunk or QRadar. So what's coming out now, based on the network level visibility, is much, much more contextualized data. One last point on this, Dana, is that what we're finding is not only does this approach provide much stronger defense in depth, which is what security wants, they're able to democratize a lot of the functions of security. So they're much more efficient, because a lot of the preventative, proactive vulnerability management that's being done by other teams very voluntarily, and they're getting pulled into cloud projects earlier. The DevOps people are very accepting of the security use cases. They're very open, and they're very fast to deploy these security use cases because now they have that capability. And the vendors, such as the New Relics, Datadogs, and others, if you look at their corporate mission as of recent, they will say that security use cases is their number one goal because there's a lot of value. Are they looking to move into the SOC and become a SOC tool? Probably not for a while, and they'll tell you that if you talk to them. However, being able to do security functions is very, very important for the DevOps and the developer side. So they're bringing that capability. The last point's kind of interesting here. So now we're finding, because the DevOps people don't want to have to go into a deep observability pipeline and deploy tools that are able to collect and aggregate network traffic. That's just infrastructure stuff. They don't want to do that. Hey, Mr. NetOps, Ms. NetOps, can you please come over and help me deploy this, because the value, the metadata that I'm getting out of that traffic, super useful to me. So now the NetOps teams are being called in early. And here's the side effect that we're seeing, Dana. I'm going to date myself. So I started my career in IT in the 1990s and for an investment company in Boston. And we didn't have a network team when I first joined. We had a telecoms team. And this team went through a transition throughout the 90s because they were wiring phones, but they were also wiring network connections, Ethernet cabling all over. What we found is that over the years, there was a split within that group. Some of that group decided to stay in telephony, and they would run the phone systems and switches and all of that. But part of that group became networking groups, network engineers, and then ultimately architects and operators. We saw a split happen. So 20 something years later, we're seeing kind of a similar split happening because of this technology, and because this technology allows the NetOps teams to be much more involved in cloud projects. We're seeing a split in careers as well, where a lot of the network people, network engineers through background, are now using this technology to be much more contributing and involved and almost forward-looking with cloud initiatives. So it's kind of cool.
Well, it's interesting. You perhaps conjured up another group that we should be labeling, the Netsec Ops people, right?
Yeah. So Netsec Ops become even more relevant, because what they're now able to do, Dana, is be more contributing with, I don't know what the right word is, but have a lot more value to the entire cloud operations and the cloud applications and application modernization by getting information from the network. What's happened is a lot of the cloud migration and the cloud mentality is that, oh, I'm moving this to the cloud. It's a cloud workload. I don't have to worry about the network. And that's true. The cloud service provider will guarantee your uptime. a certain level of uptime, response rates, bandwidth, all of that is guaranteed, so you don't need to worry about that. However, it's a little bit like a baby with the bathwater. There's important information you can glean from network communications. So the way we describe it, it's less about intelligence about the network. It's much more about intelligence derived from the network. And that's where Netsec Ops and even NetOps teams are starting to play a bigger and bigger role.
All right, well, let's dig into that a little bit, unpack the packets, if you will. When we go to the network to get the intelligence, is the data overwhelming? Is there a performance hit? What are some of the nuts and bolts, brass tacks, if you will, about accessing that data in a meaningful way and then sharing it in an impactful way?
There are basically two different use cases, and you hit the nail on the head. If done not incorrectly, cost can overrun very, very quickly. I'm talking about data cost and communication cost. So the two use cases are packets, which are still very relevant in the cloud. We're finding as people move workloads to the cloud, they're able to they realize that, hey, we're not able to have as much control and visibility into the data that we need. For example, we just had a conversation with Lockheed Martin recently, and they have CMMC, the capabilities, I forget what CMMC stands for right now, but capabilities and maturity model. So part of their requirement from a compliance perspective is they need to inspect the packets and even in the cloud workloads, except when you have multiple tools. So you have their CMMC compliance related tools. They also have an NDR, a network detection response tool. So when you have 3, 4, 5 tools, the packet flowing all over the place to the instance where the tool is running, the VM where the compliance reporting is running, and all of this can get pretty expensive because you're paying for bandwidth over and over and over. And not all tools need to see all traffic. So if you were to take all of your VM traffic, pull it all together and send it over the wire, it's going to start getting really, really expensive. And this is where the cost optimization comes in as well. It's the ability to fine tune and say, you know what, this tool is only going to see this traffic. I'm going to switch to on-prem for a second. So if there's somebody listening to Spotify on-prem, not all of your monitoring tools or even security tools for that matter need to look at Spotify traffic. If there's a Windows update, which is multi gigabytes big, not all tools need to see that traffic as well. So what Deep Observability Pipeline allows customers to do is be able to really be fine-tuned from a packet perspective, not only what type of protocols I want to see, but very specific what application I might want to exclude out, so I get very, very efficient. That's the packet use case. The second big use case that makes everything much, much more efficient is the notion of metadata. And if I might share another slide very quickly. So metadata is very, very important because it's the ability to extract out important elements from the traffic and send that off. So if you have a gigabit of traffic per second, metadata will bring that down to 1%, less than 1% of the traffic coming in, because it extracts the intelligence about the traffic. And the reason this is important goes into a point that you touched earlier, Dana, which is Melt is great for a lot of purposes, particularly if there's an agent running. If there's an agent running on a host, whether it's an application as a host or a device as the host or a endpoint user machine, a laptop as a host, it can get a lot of information. It can go deep into that host, find out how much CPU consumption is being taken, how much memory is left, and what are all the different services running on the machine. However, there are certain aspects that it's not able to deliver on. What if that host does not have an agent? What if it doesn't have the observability agent? Let's say it's not generating the level of visibility that's needed. The other aspect is, and this is really important, particularly for our U.S. federal agencies that use Gigamon, which is all 10 of the agencies use Gigamon. What we hear over and over is that network data is the ground truth, and it's something that's been around for very long. This little quip that's been around for a very long time. It's still very, very true. One of the first things a threat actor will do once they've reached the system is they'll try to cover their footprints, and the way they do that is by turning down logging levels, by trying to hide themselves in all of the logging world. Well, you can't hide the fact that Bassam's machine went out and talked to this command and control system or moved laterally. You just can't hide that. And so it's also immutable. Also, the last point is very important. It's passive in the sense that when you put an agent on a system, it's going to pick up, it's going to impose some level of resource consumption. And then from a maintenance perspective, patching, upgrading, there's a certain level of work involved in that. When you listen to network traffic, it's completely passive. So there's no impact on the hosts themselves. And again, the host being not just managed hosts, but unmanaged hosts as well. It could be a BYO, it could be an IoT, it could be a printer, it could be a surveillance camera, a heart machine, or even a fish tank. There was a case of breach at the fish tank a while ago. But the point here is that these are the two big different use cases, and the two come together to make what we call deep observability pipeline.
All right. Now, given how important this network traffic information is, major use cases to make it valuable. We mentioned earlier, of course, that this is not only for security, but for analyzing what's going on among and between your complex hybrid and multi-cloud deployments for cost optimization purposes. But I'd like to get a little bit deeper into what GigaOm does specifically that is differentiated and brings this information out in such a way that it can be used across these different personas and security and performance teams.
Let me actually share a slide for that as well, Dana. That's probably most applicable here. So what we're doing is the deep observability pipeline has 4 basic functions. So on the left-hand side, the workload could run on any platform, any container, any physical endpoint, doesn't matter. We worry about the access mechanism, where we support every native data access mechanism so that our customers don't have to worry about it. So rather than plugging in their 50 different tools that need access to network data or metadata, having to plug those tools into all of the different parts of the infrastructure, we plug it in, they plug those tools on our port, either physical port or virtual port, depending on whether it's cloud or not. So we will be responsible for accessing all the data. Then we can broker that out on the right-hand side to any tool that wants packet data or metadata about the traffic. And the transformation, there are about 24 different, what we call GigaSmart applications, where we're cleaning up the traffic. Not all tools need to see all traffic. So one of the main functions that we have, one of the most deployed functions that we have, is called packet deduplication. So simply, when you have any kind of infrastructure, you end up with duplicate packets because it's a artifact of any complex type of infrastructure. And when you have duplicate packets, you're flooding the tool with duplicate information. There's absolutely no need for it. So by deduplicating packets, there is you're saving a lot of traffic. And a lot of organizations we go into, it's 30, 40, 50% duplicate packets, sometimes more. So by deduping, you are instantly able to double the capacity of tool because you're not losing any fidelity of the data because the duplicate packets don't do anything. So anyway, so there are about 24 different traffic optimization transformation capabilities that we have. And all of this comes into any tool in any format that people want it. Now, you asked about GigaOm's unique capabilities. So a lot of these things are part of the visibility fabric that we had talked about. The investigation part is something that's unique, where we're contextualizing the data using our NDR technology that we have, in providing a lot more context around the data itself. But let me talk about our integration with observability and SIM tools, and this is something that's super unique. On the left-hand side, you've got your managed host, whether it's running on cloud or physical devices, whatever. You've got your managed host. On the right-hand side, you've got the cloud services. Some might be on premises, but cloud versions of these observability tools, of these SIMs. They need access to data, and that comes in over an agent. So you install a Datadog agent to all of your managed hosts out there, or whatever your observability tool of choice might be, and you're able to send it over. What we do at GigaOm, this is a virtual example, is we have something called vSeries, which is the intelligence, which is the brains of our product. We will get the traffic using our own tapping or using native packet mirroring if that's available. Then, using the same agent that you see in the top left here, we will collect that and we will send that data as events to these tools. So it's a completely different perspective that complements your existing observability dashboards and your queries and the alerts and everything else you've set up. When I say you, I'm referring to the DevOps person, again, being able to do security use cases. So I mentioned this before, it's not necessarily intelligence, or it's not only intelligence about the network, it's intelligence from the network. And it's the entire network. It's managed and unmanaged hosts. It's hosts that are talking without any kind of agent running on it. So a simple use case for this might be, actually there's a few use cases here. A simple use case might be, let's say your SIM, your Splunk is supposed to be tracking all of the activities, all of the hosts running in your system. What we find, what our customers find, is as soon as they bring in this level of visibility, deep observability pipeline, a simple matchup to say, here are all the hosts that we're seeing communicating on the network, and here's all the hosts that are being tracked by your SIM. And if there's a delta and you're not seeing some hosts that's operating on a regular basis, some API calls being made, some applications that are running that are unsanctioned, something weird's going on. I need to worry about that. That, Dana, is an example of vulnerability assessment and management and detection that's now within the realm of a DevOps person that's never been done before. And in order to get this out, typically the NetOps person will come in and they will make this happen, and they will make sure that the agent's installed and the V-Series is running and sending the data over, and they get pulled in early because there's a lot of value that the DevOps person on the right-hand side are able to get from this. And some of the use cases are listed here as well.
Right. So we can't do this just based on what the cloud providers serve us in terms of visibility. We can't do this just from what we had inside our respective data centers, because it doesn't take into account the cloud and hybrid cloud extension of our workloads. We need it all. So why is, I suppose, the need for a new pipeline, a new approach, critical? What is it that you're doing, I suppose, that gets us to this new level of deep observability? What do people need to put in place, I suppose, is essential to know to get there?
So the group of capabilities, it comes in basically two different groups. One is the packet type of capabilities. So it is a better level of security from an NDR perspective, from a compliance perspective. So for example, Five9, which is one of the company that's one of the largest cloud-based contact centers out there, they needed PCI compliance when they moved to a public cloud. You can't do that without having this level of deep observability and having your arms around all of the communications that are going on. And keep in mind, this is not just for the edge, north-south communication happening from their public cloud. This is for east-west traffic as well. So east-west includes VM to VM, but also container to container traffic. So as these attack surfaces grow, because of for a larger organization with multiple on-premises and cloud workloads, the attack surface grows, and having the need for this visibility into packets is almost foundational. It's a requirement. The second big round of bucket of benefits really comes from the metadata. And what I would like to do is jump into a quick demo and show you. So I've talked a lot about this deep observability pipeline, and let's just see what it looks like. And as I mentioned, there's multiple partners that we use. In this case, I shall go into New Relic. And what we're seeing here is just a dashboard that we've created. If you remember the previous diagram, we had the data coming in through an agent into the different observability tools. And in this case, this is New Relic. So this is data completely derived from network intelligence, from deep observability pipeline. And what I'm showing right now is the first ever. We've checked a lot, done a lot of research. We've talked to a lot of customers. First ever capability of having this level of network intelligence, network derived intelligence being brought in. So you can see, right away, some red flags start going off. There's SSL running in this environment. Even if there's one or two flows, one or two hosts talking SSL, that's a big red flag. That should not be happening. Some weak ciphers running. So this is the type of information that people find very, very valuable, and even more so because this is being sent to a DevOps person. So are there any DHCP? Is there any DNS redirection going on. So for example, I might have installed a browser plugin. So if I type in gigamon.com rather than just using the on-premise DNS name resolution, it's going into a third party, and that's a big red flag. It's just not a acceptable security practice. HTTP response codes. I won't go into each one of these. I did want to touch on one of the widgets here. I can talk to the second one, two of them. So I mentioned all the security use cases, but there are also performance use cases. So what we're showing here is the HTTP response time, and we also have a widget that shows the TCP response time. And so when Dana calls up and says, help, my application is running slow, if the NetOps person or even the DevOps person in this case can see that TCP response time trending flat, it hasn't changed, but HTTP response time has spiked. That means, guess what? It's not a network connection issue. It's an application issue because it's not a TCP level, it's at an application level. So instant resolution for some of these troubleshooting types of issues. What I did want to touch on, Dana, here is this part, which is suspicious usage. And this is simulated data. So what we're seeing on our in the simulated generated data is BitTorrent, so P2P traffic, which is a thing, by the way. Side story, we went into one of our government agencies, and when they turned on what we call this application intelligence capability, they said, this is great, I can see all the applications, I can see what's running, but it's not right because it says we have BitTorrent running in our environment, and this is a pretty secure environment. And then our sales engineer said, no, that's what it says. And then their NetOps person looked into it, like, come with me, just grabs our sales engineer's laptop and drags him into their SOC, into the security operations center, and says, guys, we have BitTorrent running. And everybody in the room said, NFW spelled out, that's not possible. But when they looked into it, sure enough, they had BitTorrent running. Somebody somehow installed that. So even with safe-ish, very safe environments, you will find applications that are what we call rogue applications. Where it gets interesting are these mining applications. So this is crypto mining applications. There was a case a couple of years ago, 3 years ago, where Tesla's AWS infrastructure was compromised, and rather than attacking using some direct attack onto Tesla's applications, bringing down systems, the actor installed cryptocurrency mining called Monero, which is actually this MineXMR, Monero, and they sat in there for months and months just mining cryptocurrency. In fact, this is if I can pull up this is a Google report that came out about 6-7 months ago, and they looked at all of the breaches that happen in Google Cloud, and what they found is 86% of the time, the attacker came in and they installed cryptocurrency mining. They did other things. That's why the percentage is going to be over 100. They did other nefarious activities. People install cryptocurrency mining. Why? Because this is the shortest route from point A, which is breach, to point B, which is monetization.
Yeah, that makes a lot of sense. You go where the money is. Hey, we're going to run out of time soon, and I want to get to the value demonstrated, hear a bit more about what you get when you do deep observability well. But I want to relate this first to zero trust architecture. This has been a big deal, and I wonder how what you're providing with deep observability pipeline relates to zero trust, because now it's being mandated more and more in the public sector, and it's becoming industry de facto standard in the private sector.
Yeah, great point, and exactly what you said, which is zero trust has been much more progressed and advanced in the federal space, which Gigamon has a strong presence in. So we've been going down that path, that journey with our customers quite a bit, and then we're starting to hear more and more, and not only here, but see the practice of zero trust, the journey actually taking place on the enterprise in the business world. One of the foundational approaches to zero trust. So zero trust is about policies, it's about identities and segmentation. All of the policy engine input, all of the assumes that all of the communications are being captured. So if you have blind spots, if you're not looking at inspecting TLS traffic, encrypted traffic that you should be, if you're not looking at east-west communications, container communications, that's going to lead to blind spots. And zero trust assumes that there is visibility in all of the traffic and all the communications that are going on. So that's where Gigamon comes in. We provide the core foundation to what the original paper on Zero Trust was about 12, 13 years old, written by John Kindervag, who was a Gartner, so it's a Forrester analyst. And he used to call it the DAN, the Data Access Network. So the foundation to Zero Trust is being able to have access to all of the data. And that's where Gigamon comes in. We provide the telemetry that's needed and visibility and the blind spot elimination that's foundational for every Zero Trust journey. So as a result, today, we're baked into almost all of the federal departments, agency projects as baked in for foundational to build the Zero Trust journey on. And we're starting to see that happen more and more on the enterprise side.
Right. Now, we've talked in general terms about the value. It certainly sounds very compelling. It makes a great deal of sense given the hybrid and dispersed nature of workloads these days and the difficulty in getting a handle on it. Going back to the network for that required insight is absolutely something that you can't deny. But we haven't talked about metrics, PKIs. Do you have any demonstrative definitions, qualitative or quantitative, of when you do deep observability in these complex environments, what you can get, security, performance, agility, cost savings?
Yes. So there are a number of ways that our customers, use Gigamon to measure, or the reports that we produce to show how efficiently Gigamon is helping. But also what's really interesting is by optimizing traffic, we're helping all other tools. So people are using Gigamon, our customers use Gigamon to say, hey, you have this IDS tool, you have this WAF, you have this APM tool that we pay for. If I'm going to ask for additional budget to buy more of those tools, it is because I'm running this as efficiently as possible. So what Gigamon shows is how much traffic is coming into each tool and how much it's been made efficient. So if you have a tool that does not need to look at, as I mentioned before, Netflix traffic and somebody watching Netflix at work, from an IT budget metrics perspective, they can say this is exactly what's being excluded, and this is how we're running this very, very efficiently. So the first metric really is around ROI. We have 6 to 9 months of ROI for our product itself, but then after that, it's all efficiency. And we have a very, very powerful ROI model that's been used by over 200 customers. And many of those cases, Dana, what we find is that our spreadsheet that we provide, it's a non-vendor spreadsheet model, actually shows how efficiently their IT organization is running. And people, a lot of our customers use that to justify additional budget. So when they go and put a proposal in either to buy anything in the data center, we find that they're kind of stapling the model to the actual proposal they're making from IT to their finance group on why they need more of some equipment. Because we have visibility into all data in motion, and that provides quantifies what the benefits are from a cost savings perspective, which is a really big factor given all the budget uncertainty that's happening right now.
Well, very good. I'm afraid we're getting near the end of our time. I suppose we also want to think about how this works. You mentioned it a little bit as a force accelerator among the tools. It seems to me that freeing the data for use across all of these different use cases from the network, it makes all of the insights and analysis valuable. So you work in a sort of ecumenical value orientation. What are your partners saying to that?
Most of our opportunities, most of the new customers that we work with gets brought to us by a partner. The reason it gets brought to us by a partner, whether it's a technology partner, and I'm speaking about technology partner, but also channel partners, but from a technology partnership perspective, Dana, what we do is we allow their deployments to be much more successful. The way we do that is by eliminating blind spots. So they need to see, for example, a lot of the tools, systems out there, they need to see decrypted traffic for them to be able to do their job, but they don't need to see things. I'm just coming up with an example. If it's a hospital, They don't need to see all the patient records. So there's things like masking technologies that we provide that allows much safer way of decrypting that still sticks within compliance and allows these tools to be much more efficient and much more effective rather. And from an efficiency perspective, everything I mentioned earlier makes those tools very much attractive. So the tools categories falls into the tools that are designed to ingest traffic. That's the reason that I just explained. Those are the reasons why they bring us in. And then the new category of tools is where the real innovative work is happening right now, is with these observability tools. That's all new stuff. It's an expansion of a DevOps person's ability to look at a 10-20% of an infrastructure that have agents running, and that's their visibility, to opening the eyes to the entire 100% of the infrastructure, seeing all communication that's happening, and from a security and vulnerability, those types of use cases. So that's where we're seeing a ton of traction, a ton of new partners coming to us saying, hey, I heard you do this. Let's work together.
Yeah, that's very exciting because, as you know, oftentimes when you provide these new capabilities and put them out into the field, people will be innovative and find creative new ways of using them that hadn't been determined before. And it certainly sounds like we're right on the cusp of some of that innovation using deep observability.
That's right. Exactly.
Well, very good. I'm afraid we'll have to leave it there. You've been listening to a sponsored Briefings Direct discussion on bridging the gap between daunting complexity and awesome performance requirements by getting the best visibility into all aspects of hybrid and multi-cloud continuum deployments. And we've learned how pervasive deep observability brings the highest levels of security, performance, and agility to nearly any business and organization. So a big thank you to our guest. We've been here with Bassam Khan. He's Vice President of Product and Technical Marketing Engineering at Gigamon. Thank you so much, Bassam.
Thank you. My pleasure, Dana.
And a big thank you as well to our audience for joining this Briefings Direct Cloud Complexity Risk Reduction discussion. I'm Dana Gardner, Principal Analyst at Interarbor Solutions, your host for this Gigamon-sponsored interview. Thanks again for listening. Please pass this along to your Cloud Ops, SecOps, Network Ops, and Netsec Ops communities, and do come back next time.